Today we're going to look at the shell method, and I grabbed some problems from AP questions, from free response questions, and altered them so that we would be kind of forced to do the shell method on this one. And maybe you might see a similar one on the AP test, and then maybe you won't. But let's look at a couple of these. So I'm going to clear this. All right. Let R be the region enclosed by the graphs of g of x and h of x. The y-axis and the vertical line x equals 2 as shown in the figure above. Find the volume when R is rotated around the y-axis. So we would duplicate this on the other side, something like that. Here's the edge of the shell, and maybe it's over here. So this should be more symmetric, of course. And then we rotate that shell around the y-axis. Well, from here to here is the, right there from here, that's the radius. Well, and then the area of a cylinder is 2 pi RH. So for this one, we're going to have 2 pi. We're going to integrate from, the sides are going from 0 to 2. So we're going to go 0 to 2. And then the radius of this would be whatever x value we're on. And then the height would be, let's see, it's parabola's on top. So it'd be h of x minus g of x. And I wanted, I think you guys could get this on your calculator, but I want to remind you how to use variables. So let's go y equals, let's put h, let's do, let's put, I don't know, this one into y1 and this one into y2, I guess. So we have negative 2 plus 3 cosine of pi divided by 2x. And then in y2, excuse me, minus 2x minus 1, and that's squared. So h minus g. All right, we actually want y2 minus y1, don't we? So let's get out of here. We're going to go 2 pi, math number 9, from 0 to 2, of variables, y variables, function, and we want y2 minus variables, y variables, function, y1, with respect to x, and the answer is 92.153. Now, if you want to pause this, maybe just try to set this one up, or maybe even try to get the answer on your calculator, that'd be great. But I'm just going to work my way through these notes. And like I said, if you want to pause them and practice it and then see how to do it, I think that'd be a great way to study for the final and for the AP test. A baker is creating a birthday cake. The base of the cake is the region R in the first quadrant under the graph of y equals f of x for 0 to 30. And they give you f of x. Both x and y are measured in centimeters. The region R is shown in the figure above. The derivative of f is the following. Find the volume of the solid when R is rotated around the y-axis. Again, so here's the 180-degree turn. There's the edge of the shell. And we rotate it around the y-axis. So again, the radius is right up against the y-axis. So the radius is going to be x for this one also. So we have 2 pi integral from 0 to 30 of x times, and then the height of the cylinder is f of x. When you plug that into your calculator, you get 2,400, that is what I got, centimeters cubed. Let R be the shaded region bound by the graphs of y equals square root of x and y equals e to the negative 3x and the vertical line x equals 1 as shown in the figure above. Find the volume of the solid when R is rotated around the line x equals negative 2. Well, now the radius is not up against the x-axis or the y-axis. What do I have to go to? If we're rotating around negative 2, then one edge is sitting right here. So we got to go 1, 2, 3 from the middle. 2, 3 from the middle. So here's that edge right there. And then this is doing, let's see, kind of like this and like this. So now when we create this shell, here's the right edge, and we're rotating all the way around like this. All the way around like this. Now I would put I put this into y1, I put this into y2, and you have to find the intersection point right there. And the x-coordinate for that intersection point, I'll save us some time here. X is 0.2387341 is what I got. Well, now we have the integral, 2 pi. We're integrating from 0.2387341 to 1. So that's from here to here. This is where the edges of all the shells are going to be. We need the radius. Now the radius goes from -2 to whatever x value we're picking right there. Well, to find distance, you take right minus left. It's always either top minus bottom or right minus left. So the radius is x minus -2, or of course, x plus 2. And then the height of the shell is going from the square root function to the e to the -3x function. So the top function is actually square root of x minus the bottom is e to the -3x dx. And when you type that into your calculator, you get 2.781. Let f and g be the functions given by f of x and g of x. The graphs of f and g are shown in the figure above. Find the volume of the solid when the shaded region is revolved around the x equals -1. So -1, and so that would be, oh yeah, it's right up against it. All right, so like that, and maybe like that. All right. Oh, no. That'd be revolved around the y-axis, excuse me. So we have -1 here, -2 here, and then it looks like, oh, nope, that's not it either, is it? I'll get it. We gotta go all the way over here. So we're revolving around -1. So finally, I think I got it now. Like this, here's the edge of the shell, here's the other edge, and we're rotating around -1, So the radius goes from here to whatever x value we're on. All right, 2 pi, integral from 0 to 1, because we're picking the edges from 0 to 1. So the radius, so remember it's 2 pi RH, the radius is the x value minus -1. So I'll write it like that, x minus -1. You can put x plus 1, of course. And then the top function is the quadratic. It's this one right here. So then f of x minus g of x to get the height. And when you do that on your calculator, you get 10.322. Well, now we have to revolve this around x equals 2. All right, let's do this. 0 to 1. So here's 0 to 1, like this, and something like that. There's 1, here's 2, here's 3, here's 4. So we're rotating it around 2. So like this and like this. So now here's the edge. Here'd be the edge halfway around, and we're going to rotate this around like this. So now we need 2 pi, again integral from 0 to 1, because the edges are going from 0 to 1. I need the r. Well, now here's the x value right here on our edge, so we want 2 minus x. It's always right minus left. So the radius is 2 minus x, and then the top is still f of x, top minus bottom, still f minus g dx. When you plug that into your calculator, you get 11.040.